Hi guys, welcome to this set of videos, and what we're going to do in these videos is they'll follow along with the notes that come out of your guys' textbook from Chapter 6, Section 7. And what we're going to do here in this section is kind of wrap up this discussion we've been having all chapter about radical expressions. And we're going to finish up this discussion by solving both solving equations that have radicals in them, so radical equations and radical inequalities. A couple of objectives or learning targets to kind of help us focus as we go through this set of notes. Here are the things you should be able to do by the time we get to the end of this set of videos and these notes. You'll need to be able to solve equations containing radicals. We'll start with that one. We'll show you how to solve the equations, and then after that we're going to look at solving inequalities that again contain radicals, which has been the theme of this chapter here, Chapter 6. So let's jump right into this. Solving equations that have radicals in them, and a couple of things I want to watch you that are going to help you do that. The first thing, in order to solve an equation with a radical in it, what you're going to do is you're going to raise each side of the equation, right? Because algebra says whatever you do to one side, you have to do to both sides. So you will raise each side of the equation to a power that is equal to whatever the index of the radical is, to a power equal to the index of a radical. Now remember, what happens, we just looked at this when simplifying radicals. If the index and the power are the same, they cancel each other out. And what you've done is you've eliminated the radical. And so really what's going to happen here is as we go through these problems, in order to solve an equation that has radicals in it, we need to get rid of the radicals. And how do we get rid of those radicals? Well, we raise them to a power that matches the index. If the index and the power match, the radicals go away, and then we'll solve the equations like you would any other algebraic equation. So before we do that, one thing I want you to be aware of, sometimes when you obtain a number that does not satisfy the original equation, it's going to be an extraneous solution, which is a fancy way of me warning you with this. You'll be able to solve all of these problems, but when you get your answer, you're going to have to check your answer. Sometimes they work, sometimes they don't work, right? So what's going to happen here is we do these next couple of problems, I will always check my solution in the original expression or in the original equation to make sure it actually works. Sometimes we'll do all of the algebra perfectly, right? The algebra is all right, but we get an answer that's what we call an extraneous solution. It is not actually a solution that works in the original problem. So just be aware of that, watch out for it, make sure you check all of your solutions, because whether you're taking this class with me or with someone else, I am sure that your teacher on a quiz or a test will give you a radical equation that has an extraneous solution, and they're just testing you to check and make sure that you are checking your solutions and watching out for extraneous solutions. So let's jump right into this. Let's show you how these are going to go. I've got one for you right here. It's an equation. We're going to solve for x. That means I need to isolate the x. I got to get the x by itself. In order to do that, the first thing you want to do is you're going to want to make sure that you get those radical expressions by themselves. That means if there's anything else not under the radical, move all of it to the other side of the equation. In this case, that would be the 2. I need to move it first, and since it's a plus 2, we're going to start by subtracting 2. So minus 2, that's going to give me the square root of an x plus 1 is equal, 4 minus 2 would be 2. Now we come to the part of solving this equation that really is kind of the point of these problems. I have a radical expression, right? I have a radical, and what we're going to do is we're going to raise each side of the equation to a power. Oh, I apologize, I lost my, hold up one second, I can fix that. I am using an Apple TV to do this, and sometimes my Apple TV doesn't cooperate and it winds up cutting out on me. I can get it back though. There it is. Again, I'm sorry about that. So now what happens here is I'm going to, right, because I have this radical expression, I told you guys that what you need to do is we need to raise each side of the equation to a power equal to the index. Well, my index is a 2. So we are going to go ahead and square both sides. The reason I have to square both sides is because algebra says whatever you do to one side, you have to do to both sides. So here we go. Because the power and the index are the same, they'll cancel each other out. I'm going to be left with an x plus 1. 2 squared is 4. Well, the last thing I need to do is subtract 1 from both sides to get that x by itself. And so x is going to be equal to a 3. But I need to check that solution, right? It's possible that it's extraneous. So let's just check it and see. I plug a 3 back into the original problem. 3 plus 1 is a 4. The square root of 4 is 2. And 2 plus 2 is a 4. So I check my solution and it checks out. So x equals 3 works. Let's try another one. I have a problem for you right here. And what we're going to go ahead and do is solve this guy by, again, raising both sides to the power that's equal to the index. Now, what I would generally what I would want to do is make sure that those radicals are by themselves if I had anything with it. But I don't have anything with it, right? This radical is all by itself over here on the left-hand side. And so what we'll do is just go ahead and raise both sides to the second power because my index is a 2. So right away, I'm going to square and square. We'll square both sides. Okay, well, because the index and the power are the same, they cancel each other out on the left-hand side. But I've created a little bit of work for myself over here on this side since I have a quantity squared. Please be very, very careful here. Properties of exponents only works if these are multiplied, right? If it was 3 times the square root of x, I would square everything inside the parentheses. But it's not multiplication, it's subtraction. That means that this is a binomial squared, and you will need to FOIL. No big deal. We know how to FOIL. Here we go. 3 times 3 is going to be a 9. I will have a minus 3 square root of x minus 3 square root of x. And then negative square root of x times negative square root of x will be a positive square root of x squared, because anything times itself will be squared. Okay, let's go ahead and simplify this guy. The 9 is going to just stay a 9 for now. Negative 3 square roots of x and a minus 3 square roots of x will be minus 6 square roots of x. And the square root of x squared, well, the index and the power match, so they cancel each other out, and I'm left with just an x. Okay, well, now what I need to do again is I'm trying to solve for x, so I need to get this radical by itself, and I'll do that by subtracting x to the other side. Actually, I'm going to do 2 things at the same time, because this is Algebra 2, and I think you guys can do it. I have a plus 9, so I will subtract 9. I have a plus x, so I will subtract x. But algebra says whatever you do to one side, you have to do to both sides. So I also will subtract 9 and subtract an x over here. And so what I wind up with is x minus 15 minus 9 is all equal to a negative 6 square root of x. Combined like terms, x minus x, look at that. They cancel each other out. And I wind up with a negative 15 minus 9, which should be a minus 24. Okay, I got to get the square root of x by itself, and since I have multiplication here, we'll divide both sides by a negative 6. All right. Minus 24 divided by a negative 6, of course, is going to be a 4. And once again, I have a radical. How do I get rid of the radical? Well, raise both sides to the same power, or the power that's the same as the index. Since my index is a 2, we will square both sides. 4 squared is 16. The square root of x squared, the index and the power are the same. They cancel each other out, leaves me with just an x. So I get x is equal to 16, or 16 is equal to x. But you have to check your answer. Let's go back up here and see what happens. If I plug in a 16, 16 minus 15 is 1. And the square root of 1 is 1. Over here I have to plug in a 16. Square root of 16 is 4. 3 minus 4 would be a negative 1. Careful, on this side I got a positive 1. On this side I get a negative 1. A positive 1 does not equal a negative 1. And so what we have found is, yes, I get an answer of x equals 16. However, it doesn't work. It's an extraneous solution. And sometimes that'll happen. Head on over to the next page of the notes. We'll try solving a couple more of these. I'll meet you guys there.